Hi, this is Rana from Mariposa team and I will introduce presentation about hydrophobic effect. Hydrophobic interaction describes the relation between water and the hydrophobes. Hydrophobes are nonpolar molecules and usually have a long chain of carbons that do not interact with water molecule. The mixing of fat and water is a good example of this interaction. Definition: the word hydrophobic literally means water-fearing. The hydrophobic effect is the observed tendency of non-polar substance to aggregate in an aqueous solution and exclude water molecules. It describes the aggregation of water and non-polar substance, which maximizes hydrogen bonding between molecules of water and minimizes the area of contact between water and non-polar molecules. In terms of thermodynamics, the hydrophobic effect is the free energy change of water surrounding a solute. In the pharmaceutical industry, the hydrophobic effect is an important consideration when designing drugs and drug delivery systems. Many drugs are hydrophobic, which makes them difficult to dissolve in the aqueous environment of the body. However, with the help of hydrophobic interactions, drug molecules can bind to biological membranes or receptors, allowing them to exert their therapeutic effects. Drug delivery systems can be designed to take advantage of the hydrophobic effect. For example, lipid-based nanoemulsions and liposomes can be used to encapsulate hydrophobic drugs, improving their solubility and enabling them to be delivered to specific targets in the body. Additionally, polymer-based drug delivery systems can be designed to respond to the hydrophobic environment of a tumor, releasing drugs only in those regions with high hydrophobicity. And now we'll move to another part, which is applications of hydrophobic effect. First of all, pharmaceutical applications. The hydrophobic effect occurs by the displacement of water molecules from and around the hydrophobic surfaces of both the protein target and the test compound. The value of hydrophobic interaction to improve inhibitor affinity and selectivity in drug design has been well recognized and plays out over and over in a variety of research efforts, because they are insoluble in aqueous cytoplasm. Then medicinal applications. The hydrophobic effect plays an important role in medicinal applications such as drug design and delivery. This effect refers to the tendency of certain molecules such as the lipid bilayer of cell membranes to avoid interaction with water molecules. In drug design, the hydrophobic effect can be used to improve the absorption and bioavailability of drugs by incorporating hydrophobic groups into their structure. One major medicinal application of the hydrophobic effect is in the development of lipid-based drug delivery systems. These systems take advantage of the tendency of hydrophobic drugs to associate with lipid membranes, which can make them more easily absorbed by cells and tissues in the body. Another important application of the hydrophobic effect is in the design of drugs that target specific receptors or enzymes in the body by incorporating hydrophobic moieties into the structure of a drug molecule. The last one we have is biological applications. The hydrophobic effect is centrally important in biological systems. It's partly responsible for protein folding, micellar aggregation, lipid bilayer formation, etc. First example is the folding of proteins. Proteins contain hydrophobic amino acid residues in their interior, which aggregate to avoid contact with water molecules. This drives the protein to fold into its three-dimensional conformation. The hydrophobic effect also plays a role in the formation of cell membranes. Lipid molecules, the building blocks of membranes, have both hydrophilic and hydrophobic regions. When lipid molecules come into contact with water, they self-organize into a bilayer structure with the hydrophobic regions facing inward and the hydrophilic regions facing outward. Micellar aggregation refers to the formation of micelles, which are small spherical structures formed by the assembly of amphiphilic molecules. In a water-based solution, these molecules arrange themselves in a way that allows the hydrophobic portion to be shielded from the water, while the hydrophilic portion remains in contact with the water. This results in the formation of a stable self-assembled structure called the micelle. Thank you for listening.